Okay, how did I perform the tensile testing? I'm talking you through Testxpert Ii. Testxpert Ii is the software that we actually use for the tensile testing, which is attached to a machine, Zwick-Rel. There is another video which you need to have a look. Okay. Oops, oh sorry, that was too much zoom. Zoom out, zoom out, zoom out. That's it. Okay, so I need to go to the wizard to do some testing, to do some setting. Okay, before I do, I add what's the test, specimen test, milestone. Let me see if it's recording. Yeah, it is recording. That's my third attempt. I've been doing it for the other two and it wasn't recording. Okay, test result, mild specimen, role, City College Plymouth. The standard I'm following was the ASTM, metal, manual, as ruled. That's my name, and I put the Martin name there as well. Because last week he was there as well. Okay, force is 1.6, grip to grip separation is 100, cross-head absolute is 488. I will explain you what cross-head absolute is. This all values you need to actually explain how you conducted the test. So you need to actually talk about this whole video, what procedure you have done. Then you got force. Force is 0. If I click on the force 0, it will 0 that force. Yeah, but I will do that in the end. Now, I need to go for material machine start position. The material grip to grip separation, which is here between these two, it's 100. Speed at start position is 5 millimeter per second. And the other I'm not worried about. Scroll down. Preload. I need to apply some preload. The reason I apply the preload is because sometimes material is already under some residual stresses, compression stresses. I need to get rid of these ones. So I need to apply a preload of 0.1 megapascal. The speed of the preload is 0.005 millimeter per second. And it's going to reach at that preload in 5 seconds, quite quick. After 5 seconds, that's it. That's all preload I need. Okay, the next bit is that. Specimen data. Specimen data, I need to enter the specimen data. Thickness, width, correction factor, and the like negative cross section. We don't worry about the negative cross section. There is nothing negative cross section. Negative cross section is sometime the material does not have uniform cross section area, so we need to enter that one. What kind of specimen I'm using is a flat specimen. So yeah, I just enter the details. And the next one. The next one is important. Test phase emodulus. How I want to find the emodulus. I want to find the speed for the emodulus is 30 megapascal per second, quite quickly. Yeah, and test speed is 1 millimeter per minute. That's per minute, yeah, not per second. Okay, next one. If you see here, the force is 4.4. I haven't started applying the force yet. Cross-head absolute is 488. Grip to grip separation is still the same. Okay, the next bit. Force at threshold, end of test. End of test, what I'm going to do here is I want to say like when should I finish the test? My machine can only apply a load of 30 ton. If the load exceeded 80% of the maximum, stop the test. I do not want to damage my machine. Okay, these are all the variables. The results, what I want to be printed on my report, I can just take it. These are all, what's LC mean? What's LO mean? What's FLO mean? That one. So if I just zoom a little bit out, so you can, a little bit in maybe, you can actually see. If I scroll slowly, so you can actually get an idea. Yeah, there you go. What's DL mean? What's DL mean? Yeah, so change in length. Yeah, that's it. Okay, now next one, here you go. Some more. So these you need to cross-check in the results. There are some abbreviations. You need to find out what's the abbreviation are by looking into these videos. Yeah. A0, specimen thickness. B0, specimen width. S0, cross-section area. Why A, B, and S? Why not just simple? Because it's a German standard. So they made the machine, so they just call them A, B, and C. A, B, and S0. Okay. Elastic modulus. How do I find the elastic modulus? By a method called regression. Yeah, where the elastic modulus, you can find where the line actually ends, the straight line, and then that has a formula, stress over strain. Put that one in. Get the answer. Yeah, it should start from 100 megapascal. It should end when it reaches 200 megapascal. Yeah, this is just for the safety of the machine. Okay, yield point. The sensitivity of yield point, I adjusted that one to 0.5 maximum force. Yeah, so very little force change. It will tell me, it will just plot that one. Yeah, next bit. After the thing reaches the maximum, which is here, maximum load, maximum force, I want to calculate at least 50 different capture points after the break detection. Yeah, this is the point where it actually the breaks start to actually happen, the necking start to occur. So that give me actually a lot of value, so which means the machine become more sensitive. Next one. After the testing, action after the test, you can see all these are ticked. If I go through some and finish these one, it kind of ticked, which mean like I've done these assessment. Optical assessment I want to do. Okay, next one. Okay, test data memory. I did not attach the extensometer because I don't want to damage the extensometer when I do the composite. Okay, so that's not relevant to you guys. Okay, I did the control parameter. I set that one. I set this control tells the machine what I'm expecting. So you have to tell the machine that, oh, the specimen stiffness should be that, and the specimen test arrangement is that. That is how much Newton per millimeter of force you should actually apply. Just give the machine an idea. Is he holding a tomato or is he holding a stone? So that's how much force is going to apply. So it's telling a robot like apply a gentle force or apply a firm force. Okay, that one is what we did in the start, all there. Now in the end, again, there are a few abbreviations, which we already did. So just go, if I go very slowly through that one, here you go. So you can see, and another one. So you can see all the abbreviation all the way. So you might need to pause the video and have a look at what's this. This is what we already did. Okay, it says 2% rich. It's 20%. That's my mistake. Yeah. Okay. All good. Let me just stop the video, stop recording.